In this short video, I'm going to show you an example of how to find the speed from a position time graph and how to plot that speed on a speed time graph over on the far side. I'm going to go ahead and do example number 2, and that way you have an opportunity to try example 1 and 3 yourself. Now, one thing that we need to know is the following. Speed is the slope of a position time graph. So that's what we're going to be focusing when we do this particular activity. We're going to be focusing on the concept of slope. Okay, now recall, slope equals rise over run. So we're going to have to count some rise over run in terms of the scale that's used on each axis and figure out the slope of each line segment. The first thing I would do is I would count and account for every line segment that's in the graph. So for instance, in graph number 2, we have a walk in the park, and the position time graph shows 1, 2, 3, 4, 5, 6 line segments. Since it shows 6 line segments, we should expect to calculate 6 slopes. Let me show you how that's done. Remember, we're doing rise over run. So for instance, the first one, I'm going to call this, and I'm going to number my line segments. That way I can keep track of my work over on the side. I'm going to call this line segment 1. I'm going to call this line segment 2. I'm going to call this line segment 3. I'm going to call this line segment 4. I'm going to call this line segment 5. And I'm going to call this line segment 6. So what I'm going to do is I'm going to number 1 through 6 over on the side, and I'm going to find the slope of each of those line segments. Okay, and then I'll use that information to plot our speeds for those times over on the other side. Okay, so here it goes. For number 1, I'm going to use a different color here. Let's see, let's use gray. Okay, now for line segment 1, you can see we go up 200 and over. You can see that every box is going by 5 minutes, right? So this is going up 200 over 5 minutes. So that's what we're going to write over here. The slope, okay, now remember, speed, which the variable for is v, speed and velocity use the same variable. Speed, v, is the slope of the position time graph. So over on the side here, I'm going to write v for speed and velocity equals 200 meters in 5 minutes. Okay, and now we just need to divide the two. 200 divided by 5 is 40 meters per minute. Okay, there's the first one. The second one, let me erase that. The second one has a flat line, and slope is all about steepness of a line. The slope of a flat line is 0. That's 0 slope. Okay, 0 slope because it's 0 steepness. 0 slope means 0 speed, right? We're not going anywhere. And we can reason it out the following way. This person who's taking a walk in the park is at a position of 200 meters, right here at the 5-minute clock reading time. And then 5 minutes later, they're still at 200 meters. In other words, this person stays at the same position. So if you haven't moved from the same position, that means you're not moving at all. 0 slope, 0 velocity. So velocity equals 0. And I should account for the following. Let me just put this right here. So I'm not going to worry so much about units right now. So the slope is 40, and then I want to account for a time. So let me go back to the first one. The first one is only for 5 minutes. That's important when it comes to plotting the speed time graph over on the right. So 40 meters per minute, but it's for 5 minutes. Okay. The second one is 0 speed, but that one is for also 5 minutes, because you can see it goes from 5 to 10. Here we go. So this would also be for 5 minutes. Okay, so I guess we can put from time frames. We could put time intervals. So from 0 to 5 minutes, from 5 to 10 minutes. Okay, and then the next one is this really steep line for 3. We're going to go from 200 all the way up to 700. So from 200 to 700 would be a rise of 500 over, you're going from 10 to 20 minutes. So that would be over 10 minutes, which is equal to 50. And that again is going from 10 to 20 minutes, right? We're keeping track of when this is all happening. Okay, now in the fourth line segment, we're going from 700 to 800. So from 700 to 800 and then over. There's our slope triangle, rise over run. So from 700 to 800 is a rise of only 100. It's a rise of 100, but it's a run of 10 minutes. So 100 over 10, of course, gives you a speed of 10 meters per minute, and that goes from 20 to 30 minutes. Again, we're keeping track of the time intervals too. The fifth time segment is another horizontal line. So again, horizontal line means 0 slope. That's right, so we're accounting for that. Another 0 slope, another 0 velocity. So V equals 0 from 30 to 35 minutes. From 30 to 35 minutes, we have 0 slope. Okay, and the last time segment is this really steep one that's going down. Now, if we were plotting a velocity time graph, well, a downward slope indicates a negative velocity, and we would be plotting it on the negative side of the velocity time scale. But we're plotting a speed time graph, and speed is the absolute value of velocity, and therefore we don't really care about negative slope or positive slope in this one instance. So we're just going to find the slope and then just take the absolute value. I'm not going to worry about negative. The slope, the rise, is a full 800 over the run, which goes from 35 to 60. Okay, so if you subtract those two, 60 minus 35 is 25. Okay, so there's our run. Okay, so 800 over 25 is 32. So we have a speed of 32 meters per minute, and that goes from 35 minutes to 60 minutes. Now what we do, ladies and gentlemen, is we plot these particular speeds. Now here's the great part about it. These are all constant speeds. And constant speeds are very easy to plot, because constant speeds are going to be horizontal lines on a speed time graph. Let's see how this works. The first one is 40 meters per minute, but it's from 0 to 5. So what we're going to do is we're going to go up to 40 meters per minute, and for the first 5 minutes, I'm going to use a different color. Let's make it nice and bright. Okay. So for 5 minutes, I have this speed plotted here with that horizontal line. So this speed right here corresponds to that part of the graph right there, which corresponds to the slope of that line right there. The next part is 0 speed from 5 to 10 minutes. 0 speed, 5 to 10 minutes. So now I'm down here from 5 to 10 minutes. I'm making a horizontal line, 0 speed. Now I do not need to necessarily connect them with a vertical line, but feel free to go ahead. If you want to make it continuous graph, then go ahead and connect them. Technically, this doesn't really show up on graphs because that would be suggesting you have an infinite number of positions at one clock reading, which, that's not reality. But nonetheless, if you want to make it continuous, go ahead and connect the line. Our third line segment, we are going 50 meters per minute from 10 to 20 minutes. So we're going to go up to 50, and we're going to draw a horizontal line for 10 minutes. And again, if you want to connect them, go ahead. Okay, and then the fourth line segment was 10 meters per minute from 10 to 30 minutes, or 20 to 30 minutes, excuse me. So we're down here. At 10 meters per minute for 10 minutes. That would be the 10-minute time interval of 20 minutes to 30 minutes. Then we're back down at 0 from 30 to 35 minutes, which should be right here. Okay, and then lastly, we're plotting 32 meters per minute from 35 to the remaining 60 minutes. Now you're going to have to estimate this one. 30 is about here. 35 would be here. So I'm guessing 32 would be somewhere in the middle. So, somewhere around there. And it's going to go the remainder of the time all the way back to the end. So, okay. And again, if you want to connect it with a vertical line, I guess go ahead. Give it some continuousness. This would be an example of how you make speed calculations from a position time graph and plot those corresponding speeds on a speed time graph.